remember that the body consumes energy for both microscopic, or the metabolism of energy, and macroscopic, which is through the use of activities or through activities and exercise. Right now we're going to look at macroscopic work, and we'll talk about the efficiency of the body, or more particularly the inefficiency of the body. Microscopic work is completed in exercise, but it's really not a very big part of our energy consumption, as we'll see in the next section. So for example, let's say that I climb a flight of stairs. Whoops, that's the wrong way. I climb a flight of stairs. And so I'm here, I'm about to climb this flight of stairs, and let's say that the change in height for this flight of stairs is about 3 meters. That's like one flight of stairs. And I move up those stairs, about 8, 9, 10 stairs. The amount of energy that I have produced in this body is taking the body from here and then moving it up to here. So I've given it a certain amount of potential energy. And that change in potential energy is equal to m times g times h. Now the mass of a typical person is about 70 kilograms times 10 meters per second squared times 3 meters gives me a flight of stairs would require about 2,000 joules. And 2,000 joules is equivalent to a half of a food calorie, so that's a capital C calorie. Then if I've climbed 200 flights of stairs, which takes about an hour to climb 200 flights of stairs, then that would only burn, well, let's see, a half a calorie per flight of stairs times 200. That would only be 100 calories. So really a small number of calories to have a large exertion. However, charts show that, charts that show how much calories you burn for different activities show that calorie burning for stair climbing is actually much higher. That if I spend an hour stair climbing, then I burn about 400 to 600 calories, depending on, the pace that I go at and other factors that are capital C calories. So why do we have this discrepancy? Well, the reason is, why does it change my potential energy only by 100 calories, but it requires or consumes the energy about 500 calories, 400 to 600? Well, it turns out that muscles are very inefficient. They typically have only about a 20% efficiency. That is, the amount of energy that I put in, I only get about 20% back. So I only have about a 20% efficiency. So you climb the stairs for an hour and you burn 500 calories. Then what amount have you increased your potential energy? By what amount have you actually produced usable work? Well, if I put in 500 calories, but I only get 20% back, and 500 calories times 20%, or 500 times 0.2, is going to be equal just to 100 calories. That's a 20% efficiency. So make sure you remember how to calculate these efficiencies and how it applies to the human body in this context.